Okay, this so far here is the problem that I have shared with you right here, the constraints and the objective function. If I were to redraw the constraints that we have worked with so far, this diagram right here is what we came up with. The objective function and all of the corner points were identified. We had points A, B, C, D, and E, and we went through all the computation except for uh, coordinates for points B, C, and D. So let's see how we can solve for them. Uh, okay, solving for point B coordinate. It occurs at the intersection of constraints 2 and 4. Let's go look at it. Here is point B. It occurs at the intersection of constraint 4 and constraint 2. So this point right here, point B, is what we're looking for. So those constraints, 2 and 4, are 2.4x minus 0.6y. And when we solve system of equations, that's what they are, equations, so we need to use them in equality form, even though the original sign may be less than or equal or greater than. So that was constraint 2, and constraint 4 was y is equal to 4. So we know, because y is equal to 4, that point B has the coordinate where y is equal to 4. That much we do know. So we can plug y equal to 4 in this constraint right here. So we get 2.4x minus 0.6 times 4 is equal to 0. So we get 2.4x is equal to, now take this 0.6 times 4, which is negative 2.4, and take it to the other side, and the sign changes, so we get 2.4. So x is equal to 2.4 divided by 2.4, which is 1. So we have the point 1, 4 that we solved for coordinate B. So going to my notes, for point B, I can put 1 for x and 4 for y, and my answer will be 62. So far we have solved for 3 of the z value at 3 of the corner points. Now going back to studying for solving for point C, and notice that it occurs at the intersection of constraint 4 and constraint solve for point C, it occurs at the intersection of constraint 4 and constraint 1 right here. So point C, solving for coordinate for point C, which occurs at the intersection of constraint 1 and 4. Here's constraint 1, 3x plus 5y is equal to 30. Y is still equal to 4. So we know the coordinate for y is equal to 4 at that point. Plugging 4 for the value of y in the first constraint and solving, we get, oops, sorry, I should put 5 times 4. We get 3x is equal to, now 5 times 4 is 20, take it to the other side, and we get 20. 30 minus 20 is 10. So x is equal to 10 over 3, which gives us 3.33. So we found for point C to be 3.33, and then y being 4. If you plug that, you get at point C, z value is 85.3. And finally, for point D, right here, we can see that our intersection occurs at constraint 3 and at constraint 1. So constraint 3 and 1. Constraint 3 and 1. So constraint 1 is 3x plus 5y equal to 30. Constraint 3 was x is equal to 5. So we already know x is 5 at that point. So plugging x equal to 5 in this constraint, this constraint, we get 3 times 5 plus 5y is equal to 30. Now 3 times 5 is 15. Take it to the other side and we get 5y is equal to 30 minus 15, which is 15. So y is equal to 15 divided by 5, which is 3. Now we have solved for the 0.53 at point D. So I will plug in 5 and 3 in here, and I will solve for z to be 89 at that point. So I have solved all of my corner points because I'm maximizing. The maximum value occurs at point D being optimal. So my optimal solution is x equal to 5, y equal to 3, and my optimal z is equal to 89, which is the maximum value. Now, for all of those examples, we had one of the constraints that had only one variable in them. So what about if we have two constraints and we want to find the intersection of them? So solving for a system of equations when both constraints have two variables. Here's an example. Let's say constraint 1 is 5x plus 2y equal to 15. And if I graph it, I get something like that. Okay, you can try it. Constraint 2 is 3x plus 5y equal to 30. And that would be something like this. So solving for the intersection of the two, here is how I would do it. You probably have learned substitution, and what I'm showing you is essentially a substitution method. So I'd say, let me erase this so I'll have some room to work with. Okay, so my goal here is, these are my two systems of equation right here. And my goal is to, I have two variables, x and y. My goal is to make one of those variables, either x or y, to for its coefficient to go to 0. For their coefficients for its coefficient in one of the constraints to go to 1, and in another constraint for its coefficient to go to -1. So how can I do that? I will have, whatever I do, I have to apply it to the entire constraint. Now, if I want to choose x and its coefficient to go to 1, if I multiply that whole constraint by 1 over 5, or the inverse of 5, I can accomplish that. So oops. So that constraint, if I multiply it by 1/5, I get 5 over 5, which is 1, so I'll get 1x plus 2/5 of y is equal to 15 over 5. But of course 15 over 5 is 3, so I can just write it as 3. Now this next constraint right here, what if I want that x to have a coefficient of -1 in it? Well, to get it to have a coefficient of 1, I know I can multiply it by 1/3, but if I want it to be a -1, then I have to multiply it by -1/3. So here's the result of that. Now, of course, I have to multiply it throughout the whole constraint. So I get 3 times -1/3, which is -1x. -1/3 times 5 is -5/3 of y is equal to -1/3 times 30 is a -10. So now I have these two equations right here. And let me use purple. I need to now add these two constraints together. I need to add them. So 1x minus 1x is 0x. So effectively I've gotten rid of this x variable, which was my intent. So 0x, so I don't even need to write it, correct? Okay. And then I have 2/5 of a y, 2/5 of y, minus 5/3 of y, minus 5/3 of y. So I need to take common denominator here. So I have 2/5 minus 5/3, and the common denominator is 15. 15 divided by 3 is 5. 15 divided by 5 is, I'm sorry, 15 divided by 5 is 3. 3 times 2 is 6. The sign is negative. 15 divided by 3 is 5. 5 times 5 is 25. So I end up with -19 over 15. So over here I have -19/15 of y is equal to, and then 3 minus 10 is a -7. So y becomes -7 divided by -19 over 15. Now, to solve for this, we can write this if I put a little denominator here of 1, because -7 is effectively equal to -7 divided by 1. Any number divided by 1 is itself. Then I can solve for this as -7 times 15 divided by -19 times 1. Because these two farthest numbers, when you divide two fractions by each other, the farthest numbers from each other go in the multiplication of them, product of them, go in the numerator, and these two numbers that are closer together, the product of them goes in the denominator. So now we have negative 105 divided by -19. So of course we get approximately, if you take 105 divided by 19, we get approximately 5.5. So our y, remember that we were solving for y. So y is equal to 5.5. Now you can take that 5.5 and plug it either in this constraint, or you can plug it in this constraint. It doesn't make a difference. So let's go ahead and just pick the first one. So we get 5x plus 2y, but remember we solved for y to be 5.5, is equal to 15, and therefore 5x becomes 2 times 5.5 is 11. You take it to the other side, we get -11. So 15 minus 11, we get 4. Therefore, x becomes 4/5, which is 0.8. So this point, we will solve for it to be x equal to 0.8 and y equal to 5.5. Here's another example. you don't need to always make one of the variables go to 1 and the other variable go to -1. For instance, you need to be smart in how you do them. For example, this one and this one. Look at what they have in common. Y variable has a 2 coefficient and a 4 coefficient. So if I were to multiply this top constraint by a -2, I'll be home free. But the whole thing needs to be multiplied by -2. Let's see what we get. We get -10x minus 4y is equal to -30. And this one, I'm not going to do anything to it. This one remains as 3x plus 4y is equal to 18. Now look, if I add these two constraints, if I add this constraint and this constraint, -4y and +4y cancel out. So still I end up with -7x is equal to -12. So then x is 12 over 7, which is whatever it is that you solve for, and then you can plug that into either the first constraint or the second constraint to solve for y. Okay, thank you. I think that's pretty much all that I have to say to you. Thank you very much.